Okay, so in this section, we're going to work more on writing equations because we're going to find a better way to write an equation when we're given certain information. Y equals mx plus b doesn't always work. It's not always the most efficient way. And here's a scenario. So suppose you have a bank account where you have a relative who deposits $40 every month. And after 11 months, you have $565 in that account. So what we want to do is we want to find out an equation that's going to represent the value of this account. We're going to call that value V. And we want to find out the value after m number of months. So we're going to let our variables not be x and y in this case, but we're going to call them V and m. So think about what we know so far. What we know is that we're going to make $40 per month. Now that tells me it's a rate because of that word per. It's $40 each and every month. And I also know that after 11 months, I'm going to have a total of $565 in it. That is not a starting value. That is not a y-intercept. Well, you might be saying, well, I'll just keep counting backwards like I did in the past. Do you really want to keep counting backwards 11 times? I know I don't want to do that. So here's the better way to do it. The better way to do it is an equation that's in the form of what we call point slope. Take a minute and copy down that information. And what I want to point out to you in here as well is that in parentheses, it's really x subtract what we're going to call the h value. You'll see that in a minute. We'll get to a problem where we have to really worry about what that h value is going to be. So now let's see if we can write this equation then. We want our output to be the value. So we're going to say that V equals, V is kind of like our Y, our output, how much money we have. We saw that our rate of change was our slope. It was $40 per month. So we'll start with 40 there. And we want to know after m number of months. So m is my input. So m is going to go where the x goes. And I have a data point. My data point in this case is the value 11,565. So that tells me that after 11 months, I have $565. So in my equation, I'm going to go m subtract 11. And then to that, I'm going to add 565. So notice how I substituted in my slope and my point. That's why it's called the point slope form. And if we think about that for a minute, that should make sense. Let's say we want to find out how much money we have after 12 months. And I chose 12 because I know we're just going to add another $40 to it. But if I plug in m equals 12, look how I've determined my value. It's 40 times 12 minus 11 plus 565. Well, 12 minus 11 is 1. So I get 40 plus 565. And that's going to give you my total amount after 12 months, where I just add another $40. So that equation does hold true. Let's try another scenario. So maybe you've gone to some of these new indoor trampoline facilities, and they have birthday parties there all the time. We looked into it. It's $150 for 12 people to attend, but if you want to bring additional kids, it's $8 more. So take a moment, identify your point and your slope. So you get $150 for 12 people to attend. So if 12 people attend, it costs $150. So that's going to be my point. And my slope in this case is going to be how much more per person. So the slope is going to be $8 per person. There's my rate. So now let's write an equation here. We're going to model the cost C of P people attending. So instead of it being Y equals, it's going to be C equals. I'm going to plug in my slope next. My slope was 8. I'm going to subtract the value of my data point, P minus 12. And then I'll add the Y values of the data point, 150. So this equation will model the cost of more than 12 people attending. So here's an example. A family was charged $222 for a birthday party. That $222 is a cost. And we want to find out how many people attended. So we're looking for the variable p. We have to solve for p. So my equation, 222 equals 8 times p minus 12 plus 150 is the equation we need to solve. So we'll start off by subtracting 150 from both sides. We're going to undo this equation. So when I subtract over here, let's see, I get 72 equals 8 times p minus 12. Well, let's undo it again by dividing by 8. 72 divided by 8 is 9. And when I add 12 to both sides, I get p equals 21. So how many people attended? 21 people attended. Now, we don't necessarily need a context to write these equations. As a matter of fact, without a context, it's pretty simple to write and even to graph, and I'll show you that in a moment too. So I want to write the equation of a line so I can use my x's and y's then, with a slope of 2/3. So that's my m. Passing through the point -1, 5, that's h and k. Ooh, here's where we got to be careful. Do you see that the h value is -1? So when I write my equation, in parentheses, it's x subtract the value h plus k. Oops, and my k value is equal to 5. So if I want to clean this up a little bit, in parentheses, x subtract -1 becomes x plus 1. Plus 5 at the end. So notice that when I subtract my h value, I'm subtracting, in this case, a negative, and you can do your old keep, change, and makes it positive. How about our last one here? Passing through the points 5, -2, and 3, 4. Well, I got 2 points, but what I now need is a slope. So let's find our slope. Change in y over change in x. Let me subtract my y values. In the same order, subtract my x values. I get 6 over -2, so my slope is -3. Now, when I write the equation, I could use either point. Y equals m. I'll use my first one. X minus the h value, and then put the k value at the end. Likewise, I could also do y equals 3 times the quantity x minus 3 plus 4. Either one is good. Now, let's talk about how to graph from this equation as well, because graphing from this equation is pretty easy to do. And I'm going to take one of my 2 equations from before. I'm going to take my y equals -3 times x subtract 5 minus 2. So I know my point is the point 5, -2. So let me go to where 5, -2 would be. And from this point, I'm going to apply my slope of -3. So I'm going to go up 3 to the left 1. Up 3, left 1. Up 3, left 1. Likewise, I can go down 3, right 1. Down 3, right 1. Let me just take those off. So from my point, I apply my slope. -3 times x minus 5 minus 2. And notice a couple points on this graph. Here's my starting point, 5, -2. Did you also notice that this point's on the graph too? Wasn't that the other point that we used? 3, 4. So this new form called point slope is a nice, efficient way for you to write the equation of a line. All you need is a point and a slope, or 2 points.